Okay, grade 11, so this video is Theorem 6 of Euclidean geometry. I'm sorry I've taken a bit of time to get to the last two, but the next two videos will conclude your theorems. So this is Theorem 6 and then there's Theorem 7. And then I'll film a video or two on some past papers on how to answer the questions. But it's good to know how to prove the theorems. So with Theorem 6, what we are proving is if you look at this drawing over here, okay, we have a circle and we have two tangents that are drawn. Remember, tangents touch the end of the circle, the sides of the circle. It cuts on the circumference. Okay, so they're both drawn from point P here. And what this theorem is basically saying is that if two tangents are drawn from the same point, where they meet here, so this is PB, and where they meet here, PA, these two lines will be equal, is what they are saying. So it says here if two tangents are drawn from the same point outside a circle, they are equal in length. Okay, so remember, whenever you're doing a proof, you always start with RTP, required to prove, and you say what you are proving. So that's what they've done here for us. Required to prove that PA is equal to PB. Okay, then they've done the construction here for you. So just remember to learn all the constructions so that you know what to draw in when you are, if they ask you to prove something in an exam. So join OA and join OB and OP. So that's what they've done here with these dotted lines. Okay, and much like the previous theorems, a lot of them they use congruency of two triangles to prove the theorem, and that's no different with this one. We use the information that we have, and we're going to prove that these two triangles, this one and this one, are congruent. Because if I prove that this triangle is congruent to this triangle, then surely these two lines would be equal because the triangles are congruent. Okay, so if you take a look here, what do you immediately pick up that is the same? I'm sure you noticed that there is a common side, OP is common. I'm also sure you noticed this 90-degree angle. And I mean, we constructed those two lines, so how did you know that these two are 90 degrees? They've also drawn that in. Because every tangent is always perpendicular to the radius. So remember, if I have a circle and here is my radius, if I draw a tangent there, this will be perpendicular every single time. That was one of the previous things that we learned. Okay, so now we've got a side, we've got a 90-degree angle, and I'm sure you've also picked up over here that this is from the center to the circumference. This is from the center to the circumference. So these two are radar, and obviously if they're radar, they will be equal. Okay, so I'm going to state those three reasons, and then I can say that they are congruent. And then you must just double check which, because remember there's 4 ways to prove congruency, so you must just check which of the 4 ways you used. Okay, so I'm going to start with saying, let's start with those two 90-degree angles. So I'm going to say angle A1 is equal to angle B1. Why? Because tangent perpendicular to radius. Okay, that will happen every single time you have a tangent touching a radius. Okay, the next thing we said was that BO and AO are equal to each other. So I'm going to say, I'll call it OB is equal to OA because they are radar. Radar will definitely be equal. Lastly, we can say that the center one, OP, is common. Okay, so if it is common, we know that they share that line, so it's an equal side for both of those triangles. Because now I want you to think about what you have. You have a side and another side and a 90-degree angle. But remember, it could go one of 2 ways. It could be side angle side or right angle hypotenuse side, because you're using a right angle. So the trick with this is to check if you've got the hypotenuse. So I'm sure you agree OP is the longest side here of each triangle and it's opposite to the right angle. So we've definitely got the hypotenuse. So therefore this reason is going to be RHS. So I'm going to say therefore triangle PAO is congruent to triangle PBO because RHS. And now that I've proved that the two triangles are congruent, therefore PA is equal to PB. Okay, and you can just say because congruent triangles. Alright, so like I say, very similar to the previous proofs we've done. Just check what information you have so that you get this reason correct. But when in doubt, try and see if you can't prove that the two triangles are congruent. Alright, so now we've proved that this will be equal to that. So obviously now in the future, when you're solving Euclidean geometry problems, you want to go and have a look and, you know, look for these things. Look for a point that is drawn to two sides of a circumference because it's something you could use. Okay, so I'm going to go ahead and do an example. You guys can copy that down. Alright, so example 1, I didn't write out everything that they used, I'll just explain it to you. But you've got a circle here, and you've got a tangent that's been drawn from point C. So clearly CB is a tangent, and AC is a tangent, which your mind immediately should be ringing that if that's x, this will also be x, right? Because those two lengths should be equal. Okay. Also, just by looking at this now, I'm sure you guys have noticed that this is a triangle. I'll just color it in so you can see it. This is a triangle. So if this is a triangle and those two sides are equal, what type of triangle is this? It's going to be an isosceles triangle. So immediately I know that A2 is equal to B2. So before you start your question, go through this logical process of identifying what you can see and what of the theorems you have learned so that you can write in little things like that. I'm sure you're also picking up that OA and OB are radar. So they're also going to be equal, which makes this triangle isosceles as well, which means A1 is equal to B1. Okay, also think about, let me show you this again. Think about this. Remember when we saw that the tangents touched the circumference and it touched the radar? Remember we said this is a right angle because tan perpendicular to radius. So if this is your radar over here, you should also be able to identify that that's a right angle and that is a right angle, because when it touches the radar and it's a tangent, it will be perpendicular. Okay, so that makes answering the question a whole lot easier. Even though I don't know what the question is yet, I've just written down extra information for myself. Okay, so the question says prove that AOBC is a cyclic quad. Okay, so let's go back a few steps. Remember, what is a cyclic quad? A cyclic quad can mean a quadrilateral that fits into a circle. So if I have a circle here, and these are my 4 points, and it looks like that, touches all the ends of the circumference, that is a cyclic quadrilateral. What other information do we know? We know that the opposite sides are supplementary. So what does it mean if something's supplementary? If I add it together, it is 180 degrees. Okay, so I brought out this note that we did before. Let me just find it quickly. Here, which 3 ways that you can prove that something is a cyclic quadrilateral. The first way is to prove that two opposite angles are supplementary. In other words, they add up to 180. The second way is to prove that the exterior angle equals the interior opposite. Then you have also proved that. Or your last one is you can use these angles in same segment. When you remember the bow tie thing. So you prove that the two little pieces of the bow tie equal to each other. If I look at this one though, I don't really see any bow tie shapes and I don't see any exterior angles. So I'm most likely going to go with number 1, proving that the opposite angles are supplementary, that they're equal to 180. So do you remember that I put in these right angles here? What was my reason for that? Tangent perpendicular to radius. So what is 90 plus 90? 180. So we've already shown that A plus B is 180 degrees, so it is supplementary. Okay, so I'm going to go, and that's how I'm going to answer A. I'm going to say angle A is equal to angle B, which equals 90 degrees. Why? Because tangent perpendicular to radius. Okay, then I can say angle A plus angle B is equal to 180 degrees. Therefore, AOBC is a cyclic quad. Why? You must say opposite angles are supplementary. Okay, and remember once again, supplementary means they make 180 degrees. So that was very simple in answering. You'll probably get more complicated ones, but just keep in mind those 3 ways to prove that something is a cyclic quad. Okay, B, determine the size of angle B2. Sorry, I don't know if you can see this. This is a 2. Determine the size of angle B2. So now they want this one. Now, we already spoke about this. We know that these 2 lines are equal to each other because of our tangents theorem that we just learned. Let me just actually give you a reason for that. I forgot to do that. If you want to take that first page that you wrote the theorem down, on your reason, if you ever use it, is going to be tangents from same point. Okay, and that's, I mean, you can remember that, 2 tangents drawn from the same point. So please keep this in mind when you use this theorem. That's what you're going to use as the reason. Okay, so just write that down for me. Okay, so going back to B, they wanted the size of B2. And as I was saying, we've realized that those two sides are equal because of that theorem where it's tangents from same point. So we know that this is an isosceles triangle. So just on the side here, I'm going to give you a random example. If this is an isosceles triangle, and let's say this is 60 degrees, okay, I know that those 2 angles are equal to each other. And I know that the sum angles of a triangle becomes 180. So if I say 180 minus 60, I get 120 degrees. So between these 2, they equal and they add up to 120. So if I want each of those angles, all I have to do is say 120 divided by 2 gives me 60. So each of those would be 60 degrees. Okay, so we're going to use similar reasoning here. We know that those two sides are equal, so it's an isosceles triangle. We know that is 40, so we can say 180 minus 40 and then divide it by 2. But remember, before I can do anything, I must first state my reasons and state why I'm able to say that. So what I'm going to start with is say that AC is equal to BC. And remember, we're using that previous theorem, so now I'm going to say tangents from same point. I hope that makes sense. Okay, now, so what I'm going to write in is therefore A, B, C is isosceles. Okay, and then what we're going to do is we're going to say therefore, let's say angle A. Yeah, let's write it like this. So we're going to say 180 minus 40 degrees is equal to 140 degrees. Therefore, angle A equals angle B, which equals 140 over 2. And then you can actually put this reason over there. You can say ABC is isosceles, or you could write it again. Okay, so then therefore, angle A is equal to angle B, which is equal to 70 degrees. I hope that makes sense, guys. It's just basically following this logic of saying 180 minus and then dividing it by 2 because it is an isosceles triangle, because you know those 2 angles are equal to each other. Okay, so that's a fairly simple example. but always start by writing in your information. Okay, I'm going to go into a little bit more of a difficult example. Example 2. Okay, so basically what they're saying here is you've got a triangle ACB. F is a tangent, it touches here. D is part of the tangent and E is part of the tangent. So in all these places, they touch. Okay, remember this is also a radar, so you should see that that's 90 degrees. Also, what I haven't written down here and what they've told us in the question is that ODBE is a square. Okay, so they've told us it's a square. So what I'm going to do is I'm just going to draw in here. These are all equal. So this is 4 and this is 4. And if this is a square, you know all the sides are equal. So that will be 4 and that will also be 4. Okay, another piece of information they've told us is that AC is 12 centimeters. So this whole length here is 12 centimeters. That's going to help us in the question that they've asked. So they are asking us to determine the perimeter of ABC. So let's go and look at our picture and write in the theorems that we have learned. Okay, we're focusing on theorem 6 at the moment, so you should be able to picture that this CF, right, and this CD, it's coming from the same, you can almost picture a little hat. So a little witch's hat. If you see a witch's hat, you know that theorem 6 is there. So we know that if FC, if that is X, CD will also be X because of that tangent drawn from the same point. I also want you to pick that up from AF. Here's AF, and we have AE, right? So if that's drawn both from point A, and if this is Y, we can also call AEY because they are equal to each other. Okay, and then remember lastly, you've got this little hint of y plus x is 12. So when we're answering this perimeter thing, we'll probably use that. And remember, perimeter means all your sides added together. So now that I've given this a label x and y, and I know it might not be something that you would have thought to do, but maybe instead of using your like using those two lines to say it's equal, maybe label it x and y in case you need to add it up like you do in this case. So they say determine the perimeter. So remember, perimeter is going to be everything added together. So if I start with y, let's go around like this. Let's go clockwise starting with here. Perimeter is going to be y plus x plus x plus 4 plus 4 plus y. Okay, do you guys see the reasoning that I'm using here? I'm just going to keep this over here as a side note. Okay, but remember, before we can do anything, you need to state your reasons and how did all of this come about? Where did you get your x's and your y's? Okay, so what I'm going to say is, first of all, with your 4s, remember it's a square, so I'm going to say dB is equal to EB, which is equal to 4, because sides of a square are equal. Does that make sense? Okay. Now the next thing we did was we said that these two sides were equal. So I'm going to say FC is equal to CD, which I'm going to put here x because we labeled it x. I'm going to say it's equal to x. Why? What was this theorem? It is tangents from same point. From same point, right? And then lastly, this one as well is what we did. We said AF is equal to AE, which equals y. And I'm not going to write it again, but it's the exact same reason. So copy that down. Tangents from same point. So now you can go and you can do this perimeter thing and you can actually work with it. So we've got y plus x plus 4 plus 4 plus y. And what I'm going to do is I'm going to simplify it. So let's put it in alphabetical order. So x plus x is going to be 2x plus y plus y is going to be 2y plus, and then what is 4 plus 4? It's going to be 8. Okay, so does your brain not ring a bell over here that this is going to be a common factor if you look at the x and the y? And then think about this. X plus y is 12. So do you see where we're going with this? I'll show you what we're going to do here. So let's say you take out this 2 and you have x plus y. I'm not going to worry about the 8 factorizing the 8 because we're looking for this. Okay, so now we know on the side here, we know x plus y equals 12, right? Because that's what's going on here. That whole length is 12. So instead of writing x plus y, what I'm going to do is replace it with a 12. So the perimeter is 2 times 12 plus 8. So p is going to be 24 plus 8. So what is the perimeter here? 32. And I didn't write this in, but it's centimeters. They actually told us here 4 centimeters. Okay, so your unit will be centimeters, and your answer is 32 centimeters. Okay, I hope this video makes sense, guys. Please ask questions as per usual if you don't understand.